Okay, so in this video we are going to find volumes of prisms. The previous video covered volumes of rectangular prism, and rectangular prism was nothing but a box kind of thing, a box kind of thing like this. But we'll look at this in a different way now. So first thing that comes to our notice is our mind is, what is a prism? Okay. Now prism is a shape which has two bases, and they have to be exactly similar, and then they are connected with edges. So it could have anything like this is my first face, or we can call it base, or we can call it end, and then you have another one here. And this is face number one, that's the face number two, and they are connected with edges, and that's what makes it a prism. So a prism has two bases. Sometimes you call it two ends as well, or sometimes you call it faces. So you might have end face, something like this, ends or end faces, that kind of thing. And these bases are exactly similar. Yeah. And other thing is, they need to be parallel. We'll talk about that in a moment. And one property of prism is that if I cut my prism here, I cut it here, I cut anywhere in the middle here, the face that I will get will exactly be similar to the end faces. Yeah. So even if I cut it here, and when I cut at this point, I'll get a new face here, and that face would exactly be be similar to the end faces. Yeah, they have to be. And we in terms of in mathematical language, we call it uniform cross section. So prisms have uniform cross section, which means that no matter where you cut them along their length, you will get the same shape, you will get the same area. Yeah, you'll get the same base or same face, and that's what makes it a prism. Other thing is, the faces need to be parallel. So if you want it to be a prism, then you need to, like, let me do it, and you can tell me whether this is a prism or not. So this is my one face, and my other face is like this. Okay, but it's not same. Okay, we can look at that example as well first. So that's my other face. This edge is connected to that edge is connected to that edge is connected to this, and that is connected to this. Now, is it a prism? Think about it and then answer. It is not a prism, because it got two bases here. This is the one, this is the other one. They are not exactly similar. The first one looks like a square, the other one looks like a trapezium. So that is not a prism. Let's look at one more example. So this is my first face. Another one also is a square. So I'll draw it like this, and other one is also a square of the same size, but it is oriented in a it's oriented in a different direction. So I have this kind of face. This is one face, that's another one, and I connect them, and I see that they are not parallel. Sorry, they are connected, and the bases are same, but the bases are not parallel. So this is not a prism. Okay, and then the prisms that we would be concerned with are known as right prisms. So I'll draw this in a different orientation. So I got that that's my prism. So and now that is a prism because it costs two bases, and this is the bottom. Yeah, so that is a prism. Now it is oriented in this way, and what is special about this prism is that this side, that side, that edge, and that edge, they are perpendicular to the base. So this is a base, that's the base here at the bottom, and got another base at the top, and these edges are perpendicular to the base. Yeah, so it's like if your base is like this, then the height is perpendicular, that angle is 90 degrees. You might have other kind of prisms as well. So let me draw another one. I hope it comes out well. So I have this, then it goes like this. So this time it is not, you can see it's not perpendicular. This time you will see that it's not perpendicular. So yep, sorry, to make it a bit longer. So there you go. Need a bit more. Okay, and but still it looks like it's 90 degrees. It's not drawn properly. But if instead of I'll not continue with this. Take a look at this. If instead of this being perpendicular, if your sides goes like this, and you have everything going like this, then it's not right angle, and those other prisms we are not going to work with. All our prisms will be of this type, where the edges form an angle of 90 degrees with the base. So having done that, let's see whether you can identify these are prisms or not. So first thing is, you could have anything, so that, and you have a similar kind of thing here, and they are connected like this. Yeah, so that's a prism. Yes, it is a prism because you got two similar bases. I'm saying that they are similar. I have not been able to draw them similar, but they are similar, and they are continuously connected. So that is a prism. You could have other prisms as well. So let's look at now it is a cylinder, but generally speaking, you could say that's a prism too. Yeah, because you got two bases, and they are connected with the edges here. So that could also be called some sort of a prism. Then you could have prisms like this, and then it goes like this. You have another hexagon there. So you got two hexagons connected with aces, so that will also be a prism. No, I have not drawn it really well. So let me just give it another go. This is one hexagon, and that is my other hexagon, and I'm saying that they are exactly same. So that and this connected with that. You got two hexagons, this hexagon, that hexagon, they are same and they are connected. If I cross it here, I'll still get a hexagon, similar hexagon. So that is a prism. Yeah. Incidentally, its name is hexagonal prism. Sorry on the spelling. Hexagonal. We call it hexagonal prism. And now you will understand why the volume exercise we did yesterday, we call them rectangular prism, because you get a rectangle here, that's one rectangle, and that's another another rectangle there in the back, and they are connected here as well. That's one rectangle, that's one base, another base, and the bases are rectangular, so it is known as rectangular prism. Okay, so we got another, we can have a triangular prism as well. So I will have one triangle like this, then another triangle, exactly same triangle here as well, and then you connect them with the sides. So this is one base, and then got another exactly similar base, so that's a triangular prism. I believe we have done these kind of questions in class as well when we were trying to find the surface areas. So there you go, that's a rectangular prism. It's a triangular prism. Why? Because the bases are triangles. Yeah. Sometimes prisms are drawn in such a way that they don't make sense. So for example, they tell you that you got a swimming pool which is which is like this, at the depth on one end is 2 meters. I mean, it's deeper on one end, and then on the other end it's not that deep, so you could have something like this. There you go. And that goes there, and this is all connect. So it's a swimming pool, deeper at one end and shallow at the other end. Is it a prism? Yes, it is a prism. Why? Because you got two faces. One face is this trapezium, other face is the other trapezium, that one in the back, and these two bases are connected. So it's a, you could call it trapezoidal prism. Yeah. Okay, now how to find the volume of a prism? Very simple. There's only one formula that you need to use, and this is how you find it. Volume of a prism is equals to area of the base times the height. Now call it height or call it length, so depend on how it is oriented, but meaning is same. So when I talking about height or depth, so this height or length, so this I would say this is the length, but it could as well be height. Yeah, and this is the length in this triangular prism. If I look at this hexagonal prism, that's the length from here to here. Yeah, that's the length. If this we talk about this, then this is the length. If we have it vertically oriented, like this prism here, then this is your height. You call it height. But the formula is same. You find the area of the base, then you time it with the height, and that will give you the. And we can now probably look at a few examples. So the same thing we had earlier, but I'll start with rectangular prism so that you will be able to use this formula to find the volume of rectangular prism as well. So I got this kind of a prism, and let's say that this is length, this is width, and that's the height. So again, to find the volume, the area of the base, so it has got two bases. This is one base, and you got another one at the back here. So area of base is equals to, this is a rectangle here, so area of this base is equals to W times H. So volume will be area of the base times the length. So this is the length that we need to take. So area of the base is this times length. So, and we get formula which we have already been using, which we have used in previous video. That's the volume of your rectangular prism. All right, so if I have got a triangular prism, the concept is still the same. I got, that's my triangular prism here. Yeah, so again, this is my triangle, and this triangle has got a height. This triangle has got this size of say 8 meters, and that's that height of 4 meters, and this is a length which is says 10 meters. Yeah, so it got two bases here. That's the base number 1 here, and that's the base number 2, which makes it a prism. So volume is equals to area of base. Okay, let's first find the area of the base. Area of base is basically this triangle, so area of this triangle is half base times height. That's the area of triangle. So basically that gives you 16 meters square, and then volume is equals to, you do this area of base times length. So area of base is this, length is 10, so 16 times 10 is equals to 160 meter cube. Very simple. If you have a trapezium, you should be able to do the similar thing. You find the area of the trapezium. I think we can give it a go. So that's my trapezium here, and this is what my prism will look like. Yeah, so again, I got two bases. That's the first in the front, that's my first trapezium, and then that's my another trapezium here in the back. They are exactly same, so it is a prism. Length is say 8 meters. This trapezium has got, this side is 5 meters, this side is 3 meters, and the distance here is 4 meters. So first you need to find the area of trapezium, and we already know how to find the area of trapezium. This is the base here, so area of base here, if you remember the formula for the area of a trapezium, it is half a plus b, which is at the parallel side, times the distance between them. So 8, again a, we come with 16 meters square. So volume is equals to area of base times the length. So this is my length, 8 meters. So 16 times 8 is equals to, I hope I'm doing my maths right. That's how you do it. All right, so a few exercises for you guys to try now. Okay, so I'll just draw the diagrams here. So you need to find the volume of these prisms. (10 meters, 4 meters, and this is a square prism. Find the volume. So find volume. Another example is I want you to give it a go here. So again, it's a triangular prism. So this is the perpendicular here. Height is 2 meter. This is 4 meter, and this is 6 meter. You need to find the volume of that as well. Third one is I'll do a trapezium, so that we know what's happening here. And that's my trapezium. You got two bases, this one and that one. So this is 6 meter, 2 meter, and this height is 2 meters, and the length here is 10 meters. These are the three questions I want you to try.